Midterm exam review, section E, diagram analysis. Okay, Margot leaves her house at 7 p.m. and drives 5.0 kilometers south to pick up Betty. Then they go 2.0 kilometers east to get Jane. Then they go 4.0 kilometers north to Susan's house and arrive at 7:30 p.m. Okay, so here we go. We are going to, it says here, sketch the vector diagram. There's no need to measure, just approximate what it would look like. Okay, I'm going to measure for the sake of having a perfect example, but I just need to see you kind of like sketch it out approximately. Okay, so here we go. We're going to start over here, and we're going to go 5 kilometers south. So 5 kilometers south, pointing down, 5.0 kilometers, labeling it just for the sake of having a visual there. Okay, and then from there we are going to go 2 kilometers east. All right, if you need your little compass rose, here we go, north, south, east, and west. Okay, 2 kilometers east. Okay, 2.0 kilometers. And then from there, we're going to go 4 kilometers north. 4 kilometers north. All right, and that's the trip. Now, it asks for the distance of the trip. Well, distance is simply adding them up, ignoring directions. So 5.0 plus 2.0 plus 4.0 gives us 11.0 kilometers. That's your distance. Displacement, not the same thing. Displacement is a straight line from where you start to where you stop. Okay? I started here, I stopped here. A straight line from start to stop. Okay? This should look very familiar. Diagrams, we've done like these before when we did distance and displacement. If you're really stuck, go back to that. Okay? Now, that right there, how are you going to figure that out? The only way you can figure it accurately without measuring it's going to get pretty close. It's going to give you a good estimate if you have a ruler. But if you don't have but you need an exact measurement, okay, what you are going to do is create a right triangle here. Right there. We have a right triangle. Now, we know that this side, this dotted edge line of the triangle, is parallel with that. These are parallel to each other, so this right here is 2 kilometers long. Okay? This side's 4 and this side's 5. They're parallel, and these are parallel, so we know that that cuts off there. This section, this side of the triangle right here, is going to be 1 kilometer. So that tells me that I have a right triangle, so my trip displacement, I'm going to use Pythagorean theorem. A squared plus B squared equals C squared. Rearrange that formula to solve for C. C is equal to the square root of A squared plus B squared. Okay? This is provided for you on the midterm exam. You do not have to do that algebra rearrangement on that midterm. Now plug in values. Square root of the sides of the triangle, 1 and 2. So 1 squared plus 2 squared. Let's punch that into your calculator. All right, square root, you hit the second button, come down here next to the 7, see that above there, square root. All right, 1 squared, 1, same button, just not without the second, squared, plus 2 squared. All right, you can close the parentheses if you want to. If you don't, you'll still get the same answer on this formula. Ta-da! The calculator, the calculator says 2.236, blah, 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 blah. Significant figures, everything has 2 sig figs, so 2.2 kilometers, and we need direction on that. So it ends at where you stop. So pointing at where you stop, that's going southeast. All right. Now it asks for the trip's average speed. Well, speed is simply the distance divided by the time, the total time. So the distance was the 11.0 kilometers. The time left at 7, arrived at 7:30. So 1/2 of an hour is 0.50 hours. So 0.50 hours. 11 divided by 0.5 gives us 22. 22 kilometers per hour. There's your units right there, kilometers per hour. That is your average speed for the trip. Now, trip velocity. Velocity is displacement divided by time. Okay? Displacement divided by time, well, you calculate displacement 2.2. 2.2 kilometers. The time is still 0.50 hours. So 2.2 divided by 0.5, 4.4 kilometers per hour, and velocity has direction, so the same direction as the displacement, southeast. Okay, so that's your distance and displacement example. All right, last section. Last section here is on projectile motion. This one requires the use of the formulas, so you will probably need your formula chart out of your journal. It's on the notes with a page of free fall. You will need those notes in your journal because you need all the formulas for the formula chart. Okay? On the oops page for free fall, you need the formulas. Here we go. Object is shot into the air, goes up, comes down. And we have a data table. Times Vy, Vx, delta y, displacement y, displacement x. So, what is going on? Well, here we go. First, we need to label the time. So right here it says 0. This is where time is equal to 0. Here is time equals 1, time equals 2, time equals 3, time equals 4, time equals 5. We are going to do absolutely every piece of data we can before using any formulas. Okay, so here we go. Vertical displacement at time 0 is 19.6 meters per second. At time 1, that Vy is going to be smaller, so we're going to have to calculate and figure out what it is. Here, something very special about the vertical velocity, this point, we have here the apex. At the apex, my vertical velocity is going to be 0. Here it's going to be going down now, so I know at least this should be negative because it's going down. This vertical velocity is also down and this vertical velocity is down, so I know those values are going to be negative. So when you punch into the calculator, if you get something different, you know you might have punched in wrong. Okay, Vx, all right, so velocity horizontally at time 0 is 11. At 1 second, remember with horizontal velocity, it's a constant velocity. So if we have a constant velocity, it's still going to be 11 meters per second. And at 2, it's going to be 11 meters per second. And at 3, it's going to be 11 meters per second. At 4, it's going to be 11 meters per second. At 5, it's going to be 11 meters per second. Okay? Displacement. The vertical displacement, how high it's gotten, and how high it's gotten in each one of those. I can say that this is going to be positive, positive, positive. That right there. If it's 0 at time 0, if the vertical displacement is 0 at time 0, the vertical displacement at time 4 seconds is also going to be 0. And this one down here at 5 seconds is going to have to be a negative value. My horizontal displacements, they just keep moving further and further and further and further and further forward, so I know these are all going to be positive values. But we will need a formula to calculate those. Now, from this point, we got to get the formulas to calculate them. For the calculations, these will need formulas, so your formula chart Vy, all right, so vertical velocity, this is the formula we're going to be using for this one. So g time delta t initial velocity plus initial velocity. Our initial velocity is 19.6, okay? So right here, this is the initial velocity, the 19.6 for our formula. And then g is always going to be the negative 9.8, and then t is that right there. So when we plug this into the calculator, okay, so negative 9.8 multiplied by time of 1 second plus the initial velocity of 19.6, and we get 9.8. Okay? At time 0, at 2 seconds, it should be 0, so we can even test that. So at a time of 2 seconds, our answer should be 0, and it is. All right? At a time of 3 seconds, scan across and type in 3 seconds, hit enter. It is now negative, which we already decided it was going to be negative, 9.8 meters per second. And then at 4 seconds, it is now going to be a negative 19.6. And at 5 seconds, it's going to be a negative 29.4. All right, for next column. So what those numbers are showing you here, so as it's going up, that was a positive 19, a little bit slower, 9.8, 0, increased by 9.8, 19.6, 29.4. That's the vertical velocities. Okay. All right, now we're talking about horizontal displacement. And horizontal displacement displacement. So horizontal displacement, and our initial velocity is definitely not 0. We want the vertical. Vertical displacement, so it's got to be this one or this one. All right, and our initial vertical velocity is definitely not 0. It's the 19.6. So we're got to use this formula right here, the long one. All right, so initial velocity 19.6. That's that right there. Multiplied by the time. We already have the time 0, so 1 second. Multiplied by 1 second. And then plus that 1/2, we're going to put 0.5 in the calculator, multiplied by the negative 9.8 of gravity, multiplied by the time, which we're doing the 1 second. 1 second time right there. And then squared. Hit enter. And our vertical displacement is going to be 14.7. So what's that saying? It says right here, from here to here is 14.7 meters. Okay? At 2 seconds. All right? So, same formula. All I got to do is go back and change the 1 to 2s, the 1 second to 2 seconds, the 1 second to 2 seconds, and enter. And we get 19.6. So right here, at 2 seconds, that vertical displacement is 19.6. Now, you can punch into the calculator, go across 3 seconds, and go across 3 seconds, and that number should be the same. The 1 second and the 3 seconds, they're the same. Because they're the same height, 14.7, 14.7. Okay? And we figure that at 4 seconds it should be 0, so let's try it. Let's put in 4 seconds and see if the number we get is 0. It is. So vertical displacement of 0, that's right there. And then at 5 seconds, we concluded that that number should be negative. Well, let's find out. Scroll, put in 5, and we get negative 24.5. Okay? And the last one, horizontal displacement. Okay? So horizontal displacement, there's only one formula for that one, the velocity multiplied by the time. The horizontal velocity. The horizontal velocity is 11. You notice it's always 11. That's that constant velocity. Okay? So 11 meters per second times 0 is 0. 11 meters per second multiplied by 1. So at time 1 second, the horizontal displacement is going to be 11 meters. At 2 seconds, it's going to be 22 meters. At 3 seconds, it's going to be 33 meters. At 4 seconds, it's going to be 44 meters. I'm sure you can tell the pattern now. At 5 seconds, 55 meters. Okay, we're just using that formula for horizontal displacement. And what does that mean? What we're measuring is here at 0, right there, it's 11, 22, 33, 44, 55. That's what we're measuring. How far horizontally from where it took off. And that is section E, diagram analysis answers.